changing electric field, they have displacement current, but we also have those fringe fields along the outside. They extend some distance away from that signal line to the return, and it's through those fringe field lines, the changing electric field strength of those fringe field lines, when the edge goes in, those change electric field lines, that is also displacement current and generates part of the current. And so you can think about it as kind of these two current paths in parallel. They're both contributing to the current between the signal and the return. There's the parallel plate current and the fringe field current. It's their combination that contributes to the current that gives rise to the impedance. The larger the electric fields that extend out there, the larger the current, the lower the impedance. Anything that changes those fringe electric fields, so if we keep the dielectric spacing the same, the parallel plate field lines, they're going to be about the same. The displacement current from that parallel plate current or parallel plate field, they're going to be about the same. What's going to be different is the impact from the fringe fields. If those fringe fields increase for whatever reason, we'll see in a minute how we do that, then we're going to have more electric field, more change in electric field, more displacement current, we're going to have a lower impedance. If we somehow decrease those fringe fields, we'll have less displacement current between the signal and the return, and less current means higher impedance. And so there's this connection between the shape of those electric field lines, how strong they are, how many there are, how fast they change when that edge goes by. It's those field lines that contribute to displacement current that contributes to impedance. The more the field lines, higher the displacement current, the lower the impedance. And now we can look at the importance of that. We can look at how do the fringe field lines affect the impedance of the transmission line. Because when we have a single-ended transmission line, that parallel plate field lines, the fringe field lines, they're all fixed. They're not going to change. It's when we have another transmission line that we're bringing into the picture that it can influence those fringe field lines, and it can sometimes increase or decrease the fringe field lines, sometimes increase or decrease the displacement current, and sometimes decrease or increase the impedance of that line. And that's what we're going to look at next. So here we have that case of that single-ended line that we were looking at before. It's got all of its fringe field lines out there. And now we're going to bring another line, an adjacent line, in from far away.